This is the P wave on ECG, and this is the QRS complex, and here is the T wave, primary waves seen in the ECG, and this region is the PR interval. This is the ST segment. From here to here, that is from beginning of QRS to end of T wave, you can take as the QT interval. From one P wave to another P wave, it is the PP interval. I'll correct it. Onset of P wave to onset of P wave. That is PP interval. And from onset of QRS to onset of next QRS, it is RR interval. But most often we take it from peak to peak because that's easy to identify. P wave is due to atrial depolarization. QRS is due to ventricular depolarization, and T wave is due to ventricular repolarization. Then why are both these in the same direction? That is because direction of repolarization is opposite to the direction of depolarization. That is why both are in the same direction. Otherwise, depolarization wave should have a polarity opposite to that of a repolarization wave. Now, where is atrial repolarization? Atrial repolarization is not visible in the usual surface ECG, but it will correspond to the PR segment, part of the QRS and part of the ST segment. This upsloping ST depression seen here is supposed to be due to atrial repolarization or TA wave. This is supposed to form a parabola like this normally. Such an ST depression is not significant, it is a normal variant. Now, most often we go by the sequence, right rhythm, then P wave, PR segment, QRS, ST segment, and T wave. That's the usual sequence in which we analyze the ECG. That is in order not to miss any abnormalities. Then there is something which I missed in the beginning, that is this standardization pulse, which is not seen well here because it has been clipped off. A normal standardization pulse will be a square wave. No, not exactly like that because that has become curved. I would redraw it approximately because drawing manually with the mouse is not so accurate as the standardization seen on the ECG. This is a square wave, almost square. Perfect square is usually seen, especially with the modern digital ECGs. But it can also be different. Suppose the edges are smoothed out like this, the corners are not seen, then it could be a overdamped tracing. And if there is an overshoot here, then it will be underdamped. So properly damped tracing is one which you would like to interpret. And this square wave is corresponding to 10 millimeter to a millivolt. And the horizontal plane 5 large squares or 25 small squares will correspond to 1 second. That is because speed of ECG paper is 25 millimeter per second. It's not easy to draw with a mouse, making mistakes. Anyway, these are the basic principles. So if you measure the RR interval, this is the RR interval, and divide 1500 that is the, if it is 25 millimeter per second, 1500 is over a minute. So if we divide the RR interval, that is we divide 1500 by RR interval, you will get the heart rate in beats per minute. That's how you calculate the heart rate on ECG. Next, you have to know the normal ranges of the PR interval, QRS, etc. PR interval usually is 0.12 to 0.2 seconds, that is 3 to 5 millimeter. QRS upper limit is taken as 2.5 divisions, that is 100 milliseconds. That is because one small division at this speed will correspond to 40 milliseconds. So 2.5 divisions will be 100. If it is 120 or more, you take it as wide QRS. A margin has been given. So wide QRS is when 120 milliseconds or more. Then QT interval, a simple mnemonic for me is 0.43. That is 0.34 to 43. That's what I usually remember it as, QT interval. But mind you, it is a variable thing. It can change with heart rate. It is different from male and female. With ages also it is different. So you can't have a single value for QT interval. Heart rate in an adult, normal heart rate is taken as from 60 to 100 beats per minute. If it is less than 60, it is taken as bradycardia. If it is more than 100, it is taken as tachycardia. But it is different in children. A newborn infant has a normal heart rate of around 140. The heart rate decreases as age increases. Then heart rate also changes with sleep and activity, physical activity. When you exercise, heart rate physiologically goes up. All these have to be taken into consideration while assessing the heart rate and telling whether it is normal or abnormal.